Assalamu alaikum. So you can see if I rotate the potentiometer, this servo motor is rotating according to the potentiometer's value. So actually it is the Tinkercad simulation, so it's actually slow, but in the real life you will see that this potentiometer will follow faster than this simulation. Okay, so whatever, let's see how to make this circuit, how to make this project. So you have to search first of all Tinkercad. So Tinkercad, I love this website. If you don't have any Arduino at this moment, you can use this Tinkercad. Okay, so inside Tinkercad, click create, then circuits, and wait. Okay, so let's search here Arduino and take this Arduino here, and then type servo. Okay, I think let's do the thing step by step. Okay, so first of all I will read the data. So to read the data I will need a resistor, so take one resistor here, and I need one potentiometer. So this is the potentiometer. Okay, so now what is my plan? Let me tell you that what is my plan actually. So my plan is, first of all I will take Arduino 13 pin, and I will take the power from 13 pin, and I will connect it to the resistor, then one potentiometer. The resistance is R, potentiometer's resistance, let's say RP, and then I will connect it to the ground of the Arduino. That means this point is actually ground. Okay, so let me do this thing. So this is 13 pin, let's connect it to the resistor, then connect it to here, and from the middle pin, not this terminal 2, from middle pin let's take another wire and connect it to the ground of the Arduino. Let's take it black, and let's make this thing red. This is, let's say, yellow. Okay, so I have done this thing. So now you know that, let's say this point's voltage is V. Let's say this point's voltage is V. So this 5 volt, we will get a positive 5 volt from the 13 pin. So that 5 volt from 13 pin will be divided between R and RP, right? And the voltage across this RP is actually V, this point's voltage, right? And if I increase the potentiometer's resistance, then V will increase, right? So we have a minimum value which is 0, and we have a maximum value, and in my case I will take this potentiometer's maximum value 1K, and this resistor is also 1K. That means this maximum value is actually 1K. So potentiometer's minimum and maximum is 0 and 1K respectively. So I have to find this point's voltage, right? So to do this I will take the help of a not pin or analog pin. I will connect it with V, and then I will measure that when R is 0, what is the value of V, that means a naught, what is the value of this, and when RP is maximum, then what is the value of V. So let me see. So first of all, I have to connect a naught to this pin, and then let's go to the code, write here blocks, then text, continue. Okay, let me erase these things. Okay, so what first I will do, I have to take power from the 13 pin. So pin mode 13, so I will take power from it, so this will be in output mode, and then let's write here digital write, so that 13 pin will be high. Let's make that 13 pin high. Okay, now another pin, that's actually a not pin, so we will take the voltage, we will measure the voltage of this point. So this anode pin will be in input mode, and then we need to we have to see the voltage slide, so we will see that voltage in the serial monitor. So let's initiate the serial monitor by serial.begin baud rate 9600, and then let's serial dot println. So what I will print, let's make another variable. So the variable is actually what's this? So the variable is actually v, right? V is actually a naught. So let's declare v, and then v is equal to analog read. So let me read the data from a naught pin and store that in the v variable, and let me print that v here. Well, so let me run the simulation and let's see what is wrong here. Print ln. Okay, let's see the serial monitor. I think okay, so this is actually working. So when the potentiometer is at the minimum position, you see v is actually 0. So let me note this value. So v is actually 0, and when the potentiometer is at the maximum position, 499, v is 499, so v is 499. Okay, so according to this value I will control that servo motor, right? So let me put one servo motor. So let me write here servo, and let's take one servo here. So we have to adjust the angle of the servo, and the angle of the servo is from 0 to 180 degree. That means when v is 0, the angle of the servo will be 0, and when v is maximum, the angle of the servo will be maximum 180 degree. So let me do this thing here. So first of all, again I have to make integer angle. Okay, so now let's see. So first of all, let's say this is v and this is angle. So when v is 0, angle is 0, but when is v 499, angle will be 180. So the graph will looks like this. That means when v is between 0 to 499, the angle will be between 0 to 180, and the relationship is linear. So you can make a equation of a line, but I have a function, built-in function here, which is actually map. So angle is equal to map. So I will use the map function to make a linear relationship between angle and v. So when v is between 0 to maximum 499, the value of angle is between 0 to 180. So you don't need to write any equation for this line, because this map function will do the same thing for you. So if you get any value between 0 to 499, then you will get the angle between 0 to 180 degree linearly. The relationship is linear. Okay, so let me see. Let me take this thing and let me see what is the value of angle here. So let me start simulation. So when the value is 0, potentiometer is minimum position, you see it's 0, and when it's at the maximum position, so it's now 180 degrees. So we have obtained the angle. So now the question is how to operate this servo motor. So let's see. So you can see that servo motor has, if you practically take a servo motor SG90 model, so you will see one is red and another is brown. So red is actually the BCC or power pin, brown is ground pin, and you will have an orange pin here. You will have to input the signal to the servo motor by the signal pin. Okay, so let me connect this positive 5 volt to the power pin here. We have to power this um, servo motor and connect it to the ground. Okay, so let me take it red and let me take it black. So we are actually powering this servo motor, and then we have to send the signal. So let me choose this 9th pin here and connect it to the signal pin. Okay, so this 9 pin will operate this signal pin. So that means in my code, in the board setup, so pin mode, so 9, right? So 9, then write it as output, because I will, oh no, sorry, not this way. We have to take we have to take the help of a function. So let's include, sorry, library. So let's include that library, and that library is servo.h. So this servo is in capital, right? Okay, so inside this servo library I have a servo class, and I have to make an object whose class is servo. So let's make the name, let's make an object. So actually this my servo is object. So my servo is an object whose type is servo, and I can write here whatever I want, but I have choose to write it my servo. Okay, so now as I have attached this servo motor with the 9 pin, so let me write here my servo dot attach, and let me attach that with the 9th pin. Okay, so now, so I have the angle here from 0 to 180. Now let me write my servo dot right angle. So what this line will do, this line will let's say the angle is 90 degree. So this line will send a signal, and that signal will make this servo at the 90 degree position. Okay, so let me run this simulation and let's see what happens. Okay, so now it's 180 degree position. So you see this servo is rotating and going to the 180 degree. So it's actually slow in the simulation, but if you do practically it will be faster. Okay, so let me, okay, so you see now it's 152 degree position. Now it's actually, okay, so now it's 90 degree or 94 degree, and now it's in the 0 degree position. Okay, so thus you can control this servo.